Great. Yeah.
Hey, Erin.
Dance here. Yeah, I just stopped to give an introduction. This is second last session of the day. And our latest speaker to give an Unconference talk is Dr. Daniel Felsky. He is, what do I call it? Kroner Chair and lead of the whole person modeling group at the Krimmel Center for Neuroinformatics.
You can just make up whatever you want to make up.
I hear you. We might have mic issues.
Can't hear me?
It doesn't say you're muted, but I do not hear you.
Okay. Is that better?
Am I odd? Can other people hear Dan? Just checking.
Oh,
wait. I know what I did.
Everyone's saying they can hear me too.
Okay.
Can you hear me now, Erin?
If others can hear, then I will not worry about it. Okay. I will fix what's wrong with my computer. Okay, so big thank you to Dan for coming out. I asked him to tell us a little bit about data sets available to CAMH researchers and CAMH data that's being collected, because he's kind of now in both of those arms for CAMH. And some of these data sets are available CAMH-wide, but some of them are really, some of them are public data sets that are available elsewhere that we're just trying to make easier to access at CAMH, but can be accessed outside CAMH. I guess that's an introduction, or hopefully an introduction. I'll just let Dan take off and introduce himself.
Thanks, Erin. Yes, that's right. So yeah, Erin asked me to talk about a couple data sets, and I went and made a presentation about a whole bunch of other stuff. And hopefully it's a little bit interesting. I think we've got a half an hour block, or maybe 25 minutes left. I'm not going to take all that time. So we can maybe chat a bit after. I welcome any questions. I can see your chats popping up. So I'm just going to jump into it. I guess right before I do, so I'm going to share my screen. I do have a pink mustache. You don't have to change the settings on your monitor. This is from November. I and my donors raised $1,500 for men's mental health with a focus on suicide prevention. And so I told everyone that I would literally deface myself with bleach and pink dye if we reached a goal. So I did it and kept it for now. So that is a pink mustache, pink-ish. The roots are coming in. I don't think it's not as pink as it used to be. So I'm going to share my slides here. I can see it, so I'm going to assume that everyone else can see it. You can all complain in the chat if you can't see it. So this is my talk, and Erin told you who I was, a CAMH scientist. So I'm going to dive right into it. The kind of brief preface to this, it might already be abundantly obvious to most of you who are here, the kind of purpose for doing this, for doing a cohort study. I mean, the definition of a cohort study is basically to capture a large group of people over a kind of period of time, not kind of select from pre-existing data, although you could do a retrospective study and then collect data going forward, a prospective cohort study, follow these individuals, take measurements on them, and see what happens to some people. Now, there can be exposures, there can be subgroups of people, but the type of cohort study that I'm going to talk about is fairly broad, a large amount of kind of heterogeneity, no very restrictive inclusion or exclusion criteria. And the reason why that's important is because one of the major motivations for doing these types of studies is the pursuit of precision medicine, which in its kind of most basic form is the understanding that, one treatment that is targeting an illness might not be effective for two people who have the same diagnosis. And this because, of course, everyone is different, even within a same diagnostic category or age group or, affliction. There's so much inter-individual variability, and our current available therapies are not effective in psychiatry. They're not known for being particularly good, at least across domains of healthcare. That's because we don't know a lot about the causes of illness and what could work for one person or another. So the idea is we take measurements, biological markers or other types of environmental or behavioral measurements. And we stratify people. We parse the heterogeneity, is a term that you'll hear over and over again if you're interested in this work. And we understand for which people certain diseases are more likely to occur in, and where's the risk, and in individuals who might have the same types of symptom profiles, who is actually going to respond to one treatment or another, who do we have to target, or who needs more attention, etc. And one of the best ways to get at this and to make the results generalizable to the general population, to you and me, to anybody else who might kind of find themselves seeking care, is to develop a cohort study, a kind of a large heterogeneous group of individuals, kind of try to capture heterogeneity rather than remove it in your study design. So with that laborious preamble, I'm going to jump into the first of two CAMH-based studies that I'm involved in, Aaron's involved in. They're both very large team efforts. The first one is focused on an area that's an emerging, growing problem. It's intuitively quite a major problem. That's of serious early life mental illness. So in child and youth mental health, it turns out 75% of all mental disorders actually have an age of onset prior to 25. And of course, the development of serious mental illness creates lifelong problems. It has precipitous effects. It can result in disability throughout the entire life. And it's important from an epidemiological perspective. I mean, intentional self-harm is one of the top causes of death in young people in Ontario and Canada, and it's highly prevalent in youth. Mental health problems are extremely prevalent. So it makes sense that this is kind of a population you would want to intervene in. It can have these trickle-down benefits for the whole lifespan, all of society. And in terms of mental illness, there's kind of different levels of severity of this, and perhaps one of the most severe presentations is psychosis, and the presentation of psychosis spectrum symptoms. And they tend to emerge in early adulthood. But there are lots of genetic and kind of other factors that predispose individuals towards psychosis. But it turns out that 75% of people who experience a first episode of psychosis have already had some prior contact for a mental health concern in the healthcare system, right, within 3 years. So it could be anything. It's not psychosis per se. This is a first episode of psychosis. It could be depressive feelings, internalizing behaviors, all types of all comers. And if you have had an interaction with the healthcare system, it puts you at a higher risk. So this is a really intriguing population to study. And that's where the Toronto Adolescent and Youth CAMH cohort study kind of came to be. It's led by Aristotle Voneskos, who's our VP of research, and it will target a sample size of 3,000 youth between the age of 11 and 24 who are just seeking treatment for any mental health concern at CAMH. So this is not a particular diagnosis. And it's not even a particular age group. I mean, they're very young kids, and then there are young adults. It's a span of early life, and there will be repeated assessments for up to 5 years. And really importantly, and this is a feature of both the studies at CAMH I'll talk about, and going to be important in the future development of cohort studies, the youth and family were actually involved in informing the study design from the very beginning, and we consult with them on all manners of how to make the study important, meaningful to them, and also not burdensome and respectful and conducted in a very highly kind of integrated way, or an integral way. The really meat and potatoes of it from a data perspective and of a research perspective, if you're doing research in really any one of a number of areas, is that the study is both broad in terms of the types of data collected and also quite deep in terms of each of those domains individually. So we're collecting information on these participants across these kind of psychosocial domains, educational attainment, neurocognition, a large number of biological assessments, including multimodal MRI, and external linkages. So we'll understand about previous encounters with the healthcare system through OHIP. It's one of the advantages of conducting such a study in Ontario. And the schedule of assessments kind of outlined on the right. Every 6 months, there's some assessment, but the kind of burdensome biological assessments, scans, blood tests, things like that, will be once a year for 5 years and ongoing. So these data types collected in the same person offer opportunities for looking at how these different parts of biological risk and behavioral risk and early life events and psychopathology might interact with each other and kind of together contribute to that heterogeneity that we see, and also ultimately the risk for developing psychosis, which is kind of the major focus of this particular study. The second study is actually similar in terms of that core value of collecting breadth and depth of data types. But it's focused instead on addictions rather than just early life and the emergence of psychosis. Of course, addiction is a major problem both at the individual and family level and socioeconomic level. But one thing that's not kind of understood about addictions is the role that cognitive dysfunction plays, and both cognitive dysfunction that results from substance use and substance abuse over time, but also cognitive dysfunction that may actually predispose individuals to addictions. And it's not really understood. Those relationships are not fully understood. And in fact, most, if not all, available treatments are focused on curtailing craving and use and mitigating harm through that, rather than actually looking at some of these cognitive dysfunctions that lead to functional impairments and challenges for individuals who suffer from addictions. So that's precisely what we're trying to understand in the cognitive dysfunction in the addiction study, CDIA, the second cohort. This is led by Etienne Sibyl and Lena Quilty, and is a bit smaller in size. About 600 adults will be recruited. There's a 1-year follow-up. And again, the inclusion criteria here is seeking treatment for substance abuse. This is not a particular substance of abuse. It's not a particular age range. It's not a particular type of treatment. It's a very heterogeneous group of people. And again, I'll emphasize that we had individuals with lived expertise, experience with addiction, who were involved in the study from the very beginning and continue to advise us throughout the course of the study. The data collection in this study is, again, similar to TAE in terms of its breadth and depth. We have genomics, plasma biomarkers, full neuroimaging on the biological side, and very deep characterization from the clinical and cognitive side. There's also even more integration across CAMH. Again, there's dozens of investigators participating in this, and 7 separate kind of parallel projects that are happening in line with this study design. So there's recruitment of subjects and analytics. There's also an embedded intervention for transcranial magnetic stimulation. There's also a whole preclinical arm. We'll be using preclinical models to understand and inform some of the models that we use in terms of the biological causes or consequences of cognitive deficits and addictions. Those are 2 examples of CAMH ongoing cohort studies, and they've been developed from a kind of broader vision, that's been coming over the scientific community for the last couple of decades, which is that, again, it's about breadth and depth, not designing a imaging study, not designing a genetic study, not designing a psychopathology study, but rather trying to collect more of better data types in the same individuals and provide that to make these interdisciplinary linkages. And so some of the other major initiatives that are ongoing and that we have experience with, and some of which are actively available for collaborative work at CAMH, I'll kind of explain a bit about that momentarily, are the following. The first one is the All of Us study. This is a US-based study. You can see the study collection sites across the United States. This is a huge effort. It's ultimately going to recruit 1 million participants. They're at over 300,000 now in terms of data that's available. I think they've recruited over 400,000. This is a huge amount of work. As you can imagine, we have a study of 3,000 youth, and this is over 100-fold the size already, and it'll be 300-fold the size by the time it's done. Of course, the funding involved in this study is orders of magnitude more than went into the CAMH studies, but it's on a different scale. These data actually, despite eventually probably being the largest and most impressive of the data sets I'll mention, it's not currently available to Canadian researchers. So if you're interested in accessing, again, up to 1 million participants worth of this kind of biopsychosocial data collected across the general population, you should send them an email. I've been sending them emails. They're looking to expand their rollout to other countries. They will eventually. The UK Biobank, you may have heard of. This has been around for a bit longer, since 2006. They have data available for 500,000, 500,000 individuals from the UK. Again, general population. These are not individuals who are presenting with illness in hospitals. They are probably the best, deepest, the most data you can imagine. I mean, it's bewildering. If you're interested in just kind of seeing what's available, they have a biobank data showcase that you can explore and see what types of measurements are available. They have 200,000 whole genome sequences available. They have 450,000 whole exome sequences. I mean, these numbers put to shame some of the largest efforts, up to this point in history that were done specifically for the collection of this type of data. So 1,000 Genomes Project, TopMed Consortium, et cetera. And eventually they'll have imaging data, neuroimaging data for 100,000 people. Their current data release is 40,000 people. So it's a huge amount of data. And we've actually downloaded a lot of this data to CAMH on our scientific computing cluster and have been working with it. Another one, Go Canada, is 2015, kind of collaboration between multiple ongoing cohort studies that were from different provinces in Canada. They are each of kind of different sizes. The largest one's actually the Ontario Health Study, just like something like 200,000, 250,000 participants. But together they have harmonized, and I'll talk about that word in a second, they've harmonized the data from these cohorts into one large one, the CanPath cohort, currently over 300,000 people, which represents about 2% of all Canadians aged 30 to 74. And they're not quite where UK Biobank or All of Us is in terms of their biodata collection. They don't have available imaging cohorts yet. Their genetics is just a few thousand people, but it's growing over time, and that will be a very impressive data set in the coming years. I also want to fold in this one because I mentioned that the TAY cohort study before at CAMH. It's actually built on a lot of the assessments and protocols that were developed for this study, the Adolescent Brain Cognitive Development Study, or ABCD. And this is another, again, longitudinal cohort study of youth, actually all quite young. In fact, all younger than the TAY cohort study, ages 9 to 10. The difference is that this is not a study of people who are presenting with mental health concerns. It's not as specific of a cohort. It's more general, so you don't actually end up with a strong enrichment for mental health concerns or of risk for psychosis. But it's a very impressive sample of almost 12,000 kids, and they are also going to be followed up longitudinally for many years. And it's very impressive because they have, again, very full imaging, genetic, biopsychosocial kind of data collection procedure, and it's kind of setting the bar for the study of biology in the developing brain. These data sets are really important. I mean, they offer us opportunities. They save decades for us. I mean, you could imagine that these studies were being conducted at their institutions by their PIs, and then they were just using the data and publishing on the data, and that was it. It's kind of how things were before 20 years ago, 15 years ago, still are in a lot of ways. We would all have to design our own UK Biobank and our own, All of Us study, and it's just, impossible. So they're very important. So we should be thankful and very kind of, we should recognize what goes into collecting these data, because it's a lot. It's a lot of money and blood, sweat, and tears, and a lot of effort by the participants. But it causes challenges. There are difficulties. There are a lot of hurdles and challenges along the way. So I've kind of highlighted 4 things to consider, and the last bit of my talk is just going to be focused on some of the challenges, some of the trends for how we're going to work with external data. Both the TAY and the CDIA study at CAMH will have their data be made available publicly, like these other data sets. How do we foresee the sharing of this data? How would you work with it? What are the things you should equip yourself with? What should you be paying attention to? So big challenges. One is that these different data sets all have different application requirements. So this is, ethics approvals you need to have in place, different forms you need to fill out, different requirements for who's going to access the data, how they're going to access the data, how long you're going to access the data for, what you're allowed to do and what you're not allowed to do, the scientific quality of what you say you're going to do, the scope of the hypotheses that you want to address, a lot of very different types of procedures. One of the solutions to this is actually not any kind of single solution. One of them is working at the institutional level. So collaborating across groups. If you work within a lab or within an institute or a center, and you want to, you have a study question or an area of research and you'd like to download data to work on it, you're going to have to go through the same process that other people in the same hospital may have had to go through and sign the same forms. Yeah, there's actually a lot of efficiency to be had by pooling this, and we've done some of that already at CAMH. Second challenge is just the size of the data, the complexity, the financial costs of it, the challenges of working with such a huge amount of data. 200,000 whole genome sequences is many petabytes of data. It's actually infeasible sometimes to work on it on your own computers. The solution to this is centralization, and it's centralization of a lot of processes. It could be centralization or kind of consolidation of the downloading of data. I put a question mark, I'll tell you why. Curating the data, documenting the data locally so it's usable to new trainees and scientists, and of course, centralizing the computational resources that you use, and I'll talk more about that. The third challenge is the non-overlapping populations and the non-overlapping experimental protocols. So people are making different decisions when they design their study. I'll talk briefly about harmonization. And then another one is mixed data types and high dimensionality. This is the fun stuff. This is choosing methods for how you analyze it. It's actually something I'm not talking about at all today because it would just take time that I don't have, but happy to chat about it. Data centralization. Both UK Biobank and the All of Us studies have already released their centralized cloud-based computing environments, the research analysis platform and the researcher workbench. This is a trend. It's not going to stop. All of the major cohort studies will be eventually kind of considering this as a model. All the data are held on a cloud. You can't download it and store it on your own computer or anywhere else. You access the computing environment remotely, and you have to pay for storage and compute time. It's a brave new world. More new to some than others, but in some instances, at least for UK Biobank, you're not even allowed to download, even if you wanted to. Even if I had the biggest supercomputer in the world, I can't download the 450,000 whole exome sequences. It's only available on their centralized analysis platform. Data harmonization. This is just definitional. I just wanted to clear it up in case people get confused or are unclear what this is. So just the process of matching measurements from two or more data sets and manipulating them in such a way that you can analyze and interpret them together. So like 3 examples, kind of common examples, are unit or scale discrepancies. So weight, education, volumetrics. If one study measured their participants' weight in kilograms and the other one measured it in pounds, you can't just stack those data columns and run a model because they're on different scales. You have to convert pounds to kilograms. That's harmonization. Another example is latent construct measurements. So, studies that are measuring memory or intelligence or depression. Study 1 might use a scale for depression, like QIDS. Another one might use PHQ-9. They're both measures of depression. They're not identical. They're asking different questions. So are you really measuring exactly the same thing? How do you match those? I mean, there are ways of kind of doing that. Do you have to drop questions from one questionnaire? Do you have to, you have to consider how you might be able to look at depression as measured in one study with the other and put them in the same latent space. It's also harmonization. Another one is discrepancies in data processing. So you may have had data cleaning or some type of normalization conducted on data, on raw data that then kind of works its way down the line. And then when you combine 2 columns, even if they're in the same scale, it's the same construct, you've ensured kind of, measurement and variance, then you still might have problems because you may have removed outliers from one sample and not the other. You may have Windsorized one sample and not the other. You may have manipulated them in one way and not the other. And it can be kind of insidious in that way. So those are examples of what needs to be, what harmonization is, kind of removing those discrepancies, putting things in the same scale. Another one is a terminology. This is just, advice. Don't get used to using terms like normalization, harmonization, merging, cleaning. Like these are terms that are really field and data specific, and sometimes they're useful and you can use them, every day. If you kind of work on something consistently with someone else, then that's fine. But be very specific. As soon as especially if you're talking about a big data set, multiple data types, follow the word normalization or harmonization with this. I'm normalizing gene counts by performing a count per million, division, right? Or I'm normalizing this by Z-scoring it, right? By subtracting the mean and dividing by standard deviation. Be specific about what you mean. It avoids a lot of confusion. just before the last slide, I wanted to give a schematic. Maybe you want to play back the presentation to look at it a bit. I'm not going to dive too much into it. Point is, we're using these external data sets with internal data sets to make predictions based on the collection of longitudinal data in the clinic. This is something we're actively building. The point is, if we can make an accurate diagnosis or make a clinically relevant prediction or prognosis for people who are in care by using research data, matching similar individuals, so-called digital twin approaches, or just, building generalizable models, we're actually at CAMH able to port these directly into a clinical dashboard, an iPad that displays somebody's clinical information and might be able to give, certain statistical predictions for what might happen to this person. What side effects might they encounter? Are they looking like they're likely to improve or get worse over time? And this is part of how external data and large numbers of people can help inform these models by providing estimates of generalizability for some of the internal modeling that's being done. So what should you do if you're interested in working with these data? Number one, really get used to being informed about data sharing policies and data use agreements. This just starts with approaching data sets in a organized way. If you want to work with UK Biobank data, find some time to sit down, read the documentation, read their data sharing policy, read their kind of project application policy. How do they track their project? What ethics approval do you need? It's really not that much. They've done good at, kind of outlining everything and organizing it, but you still have to do it. Learn about cloud computing platforms, tools, concepts. Where this is a brain hack, I think people are fairly, into it, but this is a trend that's going to keep building. Learn the basics of approaching a new data set. Also should be pretty, these are things we should do. I'm reinforcing these things because you don't actually see it that much. Read the documentation first, find the data dictionaries, know what your columns are, know what your variables are, know where they came from, read them first. Learn, be consistent, look for missing data, understand your data types, categorical, continuous, it's really basic statistical stuff. Make sure you nail it down, get to know it and get used to exploring your data, upfront in a structured way. And then also, whenever you're dealing with these kind of broad cohort studies with lots of different data types and opportunities for integration, learn about the major biases in different data types. This BrainHack event goes a long way to getting into considerations for neuroimaging, for pipelines, for data processing, handling data. But there's all kinds of other things to consider from an analytical standpoint, especially in a cohort study. There's different scanners and there's scanner variation. There's things that, biological and technical variables you need to think about. And in genetics, it's a totally different set of biases you need to think about. Ask an expert, reach out, ask someone. You could read articles on your own. Of course, you'll always have to, but it's often faster to just reach out, find somebody who is an expert in that field and collaborate. So the whole name of the game. This is my group. And thank you for listening at the end of a Friday before your final event. And I hope that the slides are useful, for posterity. And thanks, Aaron, for the opportunity to present.
Yeah, no, I think this was totally useful for the whole audience. We get virtual applause. Virtual applause. Good job.
Thanks.
Yay.
Great.
Yeah, I think they're very clear and very key guidelines and going into the future of science. Yeah, and I love that you brought up the cloud. Because I feel like we've been ignoring the cloud, but it's coming back to us. We're kind of spoiled in Canada with access to multiple high performance computing machines, but to actually deal with the data the way that it's actually being served to us, we're going to have to start hacking in the cloud sooner than later.
Yep. And, you can sign up for a free UK Biobank analytic platform account. They'll give you a 40 British pound credit when you sign up. And you can play around and do their tutorials and everything. It's definitely coming for all the new big fancy schmancy data. So totally, Aaron. Great. Well, sorry, I ate up all the time. So, I've got other things. I tend to do that. So if you got to move on, then you've got the slides. I can also send them to you, and you can make them available on whichever platform you're going to make this stuff available. But.
Yes, and we'll also have. So after we leave the stage for about a minute, and things go blank, it will automatically start preparing the recording for us to be able to watch in the replay section. I can also download it and get it to you if you want to spread the word with your group and bring anybody who hasn't watched it before. But no, thank you to everyone who's actually shown up for our last session. It's been a long week, and it's nearing the holidays, and everyone who's been here around. I don't know if anybody has a question to ask Dan before we get into our wrap up. I'll give him about 5 minutes.
I love the virtual applause. That's lovely. That's question enough. But also, if there are questions that come up in the wrap up, you can get in touch with me through the I don't have my email up on the slide, but Aaron can also ask me the question, or we can find a way to interface. If it's incredibly important. Otherwise, hopefully the slides are helpful, and the recording is as well. So thanks for having me, Aaron. Thanks everybody, and enjoy the rest of the BrainHack program, and enjoy the weekend and holidays and everything.
Awesome.
Great.
Cool. Okay, we're gonna leave the stage for a minute just to force the recording to prepare. See you in a minute.